Okay, good morning. I blew up my chemical experiment. Oxidants happen. How appropriate. Oxidation, reduction. Okay, we're going to go over the homework, balancing half reactions 1 through 3. We'll get the second half of the electrolytic cell notes, and then we will have some homework 4 through 8. So we should be pretty used to those by then. And let's get something small here. We'll do it. All right, number 1. Cobalt plus lead 2 chloride. Anything with itself is 0, so we know that by now. Okay, first of all, are we balanced? 1 cobalt, 1 lead, 2 chlorines, 2 chlorines. So we don't have to do anything with balancing the atoms. Okay, that 2 came from the lead, so that's a positive 2. Chlorine is typically a negative 1. That 2 came from the cobalt, so that's a positive 2, and chlorine again is a negative 1. So, anytime we have an atom by itself and then later on combined with something like in a single displacement or single replacement reaction, we know it's redox. So let's start with that. Cobalt 0 to cobalt 2 plus. Well, the oxidation number went up, and by now, hopefully you know that if the oxidation number goes up, that means it's lost electrons, and therefore the losing of electrons ends up as a product. So we have electrons on the right side, on the product side. Positive 2, negative 2 equals 0. This equals 0. What's getting oxidized? Cobalt. Whatever gets oxidized is the reducing agent. Okay, what's left? Chlorine, negative 1, negative 1. That doesn't change at all. Again, that's called a spectator ion. So we must be talking about lead 2 plus. Not sure why it's doing that. Glitching. And lead 0. So if I've got positive 2 over here and 0 here, I need to add electrons. So lead plus 2 is gaining electrons. And what can we do here? Well, you see that there are electrons on the product side and electrons on the reactant side, so I can cross those right out. Here's lead 2 plus yields cobalt 2 plus lead 0. Is this balanced? 1 and 1, 1 and 1. Check. Positive 2 on this side, that's a 0. Positive 2 on this side. Done with this one. Okay? Next one. Wow, that is frustrating. I just recalibrated that. All right, I'm going to try to go through it, at least down to here, and then I might have to pause. Okay, zinc. Let's see where this ends up. Okay. Whoa! Zinc is a 0. H2 is a 0. Hydrochloric acid. Well, actually I didn't balance it first. There's 2 chlorines here. Oh man. Very frustrating. Alright, if I write it here, okay. That's a 2. And 2 there, and 2 there, 2 there, and 2 there. I think we're good. So zinc is 0. That 2 came from the zinc, so that's a positive 2. Chlorine's a negative 1 again. Chlorine's a negative 1, and hydrogen is a positive 1. So zinc 0, and it goes to positive 2. It must have done that by losing 2 electrons. Zinc goes from 0 to positive 2, so it gets oxidized, and because it's oxidized is the reducing agent. And hydrogen is actually changing this time. So we've got 2 hydrogens, must have gained electrons to become H20, and it did that by gaining 2 electrons. So my 2 electrons can get crossed out. I'm left with zinc 0 plus 2 hydrogens yields zinc plus 2 plus H2 as a 0. 1 zinc, 1 zinc, 2 hydrogens, 2 hydrogens, 0, what's that? Okay, that's a positive 1, sorry. So that's a positive 1. So I've got 2 positives on that side, 2 positives on that side. That seems to work. All right, last one. Okay, aluminum is 0, oxygen is 0. That 3 came from aluminum, so that's a plus 3, and that's a negative 3. Aluminum 0, aluminum, actually there are 2 of them, my fault. I have to balance it. That's a 2 in front of that. This has to be a 3 actually. 3 times 2 is 6, and let's put a 2 here, 2 times 3. So this actually should end up being a 4. That's a 4. Let's see if this works. Okay, so that's 4. 4 aluminums. 4 aluminums. These are 0. Each of these is a positive 3. Okay, so 4 aluminums, 0 charge over here. 4 aluminums, each of those is a positive 3. That's 12 positives. That means I need 12 negatives. All right. So oxygen, I've got 3 of them, 3O2. Each of them is a 0. Oh, by the way, aluminum has lost electrons, and therefore is the reducing agent. Oxygen is gaining, therefore it's, it is the getting reduced, therefore it's the oxidizing agent. Oxygen typically is the oxidizing agent. And it's going to gain electrons. How many? We'll see here in a sec. Over here I've got 3 times 2 is 6 oxygens, and each one of them is a negative 2. So oxygen, negative 2, 6 times negative 2 is 12, and it looks like it's going to work out. 12 electrons, 12 electrons. I can cross my electrons out and give my final answer. 4 aluminums plus 3 oxygens yields 4 aluminums plus 6 oxygen negative 2s. 4 aluminums, 6 oxygens, 6 oxygens. Over here, what's this? That's a 0. So 0 on this side, 12 positives, 12 negatives, that equals 0. All set. Okay. Let's see how much time's left. 9 minutes. All right, I'm going to do a separate video for the other one.